Let's compute and make sense of the 95% confidence interval of the mean. Here's our goal. We want to find the 95% confidence interval for the daily average phone time. Now, I surveyed my students, and those students had these results. There were 28 of them with a mean of 4.65 hours and a standard deviation of 2.48. Now, 4.65 hours seems like a lot. If you check your own daily screen time, go to settings and then screen time, you're going to see that you're probably in line with my students. Now, we don't have, of course, the actual average for everybody's screen time. So instead, we're going to use that 4.65 as our point estimate. We're going to use that to estimate the actual mean, or mu. Now, I could have surveyed any number of groups, and each of those groups would have had a different average screen time. So instead of just using this 4.65 as our point estimate, we're instead going to construct this interval. And we want this interval to contain 95% of those sample means. At the end of the video, I'll tell you what this 95% confidence interval actually means. But for now, let's continue with our example. So what I really want to find is this confidence interval. I want to find the lower screen time in hours and the upper screen time in hours that gives me this 95% area. Let's start with those upper values first. Now, we could use a Z statistic. We've got some nice normally distributed data here. But what we don't have is that population standard deviation. So we can't use the Z statistic. Instead of using the population standard deviation, we're going to use our sample standard deviation to estimate that, which means that we'll be using the T statistic instead of the Z statistic. Now, there's another way to come up with why you're using the T, and that's that sample size. So for sample sizes less than 30, the T statistic tends to be pretty different from the Z statistic. Either way, we want to use that T statistic. But I'm not computing T. What I really want to find is that question mark, is that upper time. I'm going to do a little bit of algebra. Let's cross multiply by that standard deviation divided by the square root of n, which gives us this. To isolate that question mark, that upper time, I just need to add m to both sides. And I've got a formula now for my upper time. It's that mean, that 4.65 in our example, plus t times s over the square root of n. Let's go ahead and put it up there in our inequality. Now, I also want to find that lower value. To find the lower value, I'm going to use a really similar formula, but I've got a negative t since I'm less than the mean. So this formula also goes up into our interval. We are so close to being able to compute our values. Notice that I can now plug in my sample information. I can plug in m, s, and n. Let's go ahead and do that, which leaves us with only that T statistic. Now, in order to find the T statistic, we're going to use a table. You might also be using your calculator. Either way, you need a couple of pieces of information. You need to know that degrees of freedom. And the degrees of freedom in our case is n minus 1, which is 28 minus 1. That gives me 27. We also need to know the confidence level, which is 95%. And depending on your table, it might either ask you for the confidence level, which is that inner area, or it might ask you for the outer area, which is our alpha. Now, our alpha, those tails, it's 100% minus 95%. So those two outer tails together have an area of 5% or 0.05. But I would consider that as 0.05 split into 2, so 0.05 divided by 2. Let's use this information and find t in this table. Every table is a little bit different, but in this particular table across the top, they are asking me for the upper tail probability. Well, that upper tail probability, remember each of those was a 0.05 divided by 2. 0.05 divided by 2 is 0.025. So that's the area in the upper tail. You might be lucky enough to have a table that also has the confidence level of 95%. Okay, so we're in the correct column. Those degrees of freedom, remember, was n-1, which was 27 for us. So moving over, I end up with a t of 2.052. With that T statistic, which is often called T alpha divided by 2 because of those two tails, we can plug everything now into our formula. So our formula now looks like this. As we continue, I'm going to calculate that value that's added and subtracted from our sample mean 4.65. That value turns out to be 0.9617 because this is how much we move to get to the upper value and to the lower value from that mean. This is called our margin of error. Adding and subtracting that margin of error, we get our lower average screen time of 3.6883 and our upper average screen time that contains that 95% interval. We could also express this using that sample mean as our point estimate plus or minus the margin of error. Now, I promised I would tell you exactly what this means, and there's a few different ways to word your conclusion. A really common way of wording your conclusion is saying this: we are 95% confident that the true mean phone time is between 3.6883 and 5.6117. But here's what the confidence interval of the means actually represents. It doesn't mean that there's a 95% chance that the population mean is going to be between these two numbers. Instead, it means that if we repeated this process with a bunch of different sample means, we would find that 95% of those intervals contained the actual mean screen time. Now, there's a much easier way to find these values using your calculator. I've got a video for you here.